Hi learners, myself Nandhini, Department of Computer Science SF in the Standard Fireworks Rajaratnam College for Women, Sivakasi. Today we are going to talk about recoverability in DBMS. This session contains what is recoverability and their types: recoverable schedule and cascadeless schedule and strict schedule. Let's start the session. First, what is recoverability? In DBMS, multiple transactions often execute concurrently. During execution, failures like system crash, power failure, or transaction abort may occur. Recoverability in DBMS refers to a property of transaction schedules that ensure the database can be recovered to a consistent state after a failure, like a system crash, without losing committed data or keeping incorrect updates. Why recoverability is important? When multiple transactions run concurrently, failures may occur. Recoverability ensures committed transactions are not undone. Uncommitted or incomplete transactions do not affect the database. Database consistency is preserved. The first type is recoverable schedule. A schedule is recoverable if a transaction commits only after all the transactions whose data it has read have committed. This ensures that no committed transaction depends on an aborted transaction. If transaction T2 reads a data item returned by T1, then T2 must not commit before T1 commits. If a transaction commits after reading uncommitted data from another transaction that later aborts, the database becomes inconsistent. Recoverable schedules avoid this kind of situation. Here is an example for recoverable schedule. There is a two transaction T1 and T2. T1 write X, T2 read X, T1 commit, then T2 commit. Transaction T1 writes a new value to X. Transaction T2 reads the value of X returned by T1. T2 waits for T1 to commit. After T1 commits, T2 commits. Since T2 commits after T1, the schedule is recoverable. There is some drawback in recoverable schedule, that is allows dirty read and may cause cascading rollback. The second schedule is cascadeless schedule. A schedule is cascadeless if a transaction reads data only after the transaction that last wrote the data has committed. No transaction reads uncommitted data. Cascading rollback is expensive and complex. Cascadeless schedules completely avoid cascading rollback by preventing dirty reads. Here is an example for cascadeless schedule. Here is also two transactions T1 and T2. First T1 write X and then T1 commit. Next T2 read X and T2 commit. T1 update X and commits only after T1 commits. T2 read X. T2 commits safely. Since T2 reads only committed data, this schedule is cascadeless. There is an advantage in cascadeless schedule, that is no cascading rollback, safer than recoverable schedules. The third one is strict schedule. This is the most preferred schedule in DBMS. A schedule is strict if a transaction cannot read or write a data item until the transaction that last wrote the item commits or aborts. It prevents dirty read, dirty write and simplest recovery. Here what is dirty read? Dirty read means it occurs when transaction reads data returned by another transaction that has not yet committed. Why it is called dirty? The data is considered dirty because it is not final. It may be undone if the writing transaction aborts. Reading it can make the database inconsistent. Next, what is dirty write? Dirty write means it occurs when a transaction overwrites a data item that has been modified by another transaction which has not yet committed. Why is it called dirty? The write is called dirty because the earlier transaction's update is not final. If the earlier transaction aborts, the system cannot restore the correct value. It causes loss of data consistency. And here is an example for strict schedule. Here is a two transaction T1 and T2. T1 first write X and then T1 commit. Next T2 read X and T2 write X and T2 commit first. T1 reads X and commits until T1 commits. T2 cannot read or write X after commit T2 safely read and updates X. No dirty read or dirty write. Schedule is strict. Why strict schedule is most preferred? No cascading rollback, easy recovery using locks used in real DBMS systems. Next, conclusion. Recoverability ensure database consistency after failures among all schedules. Recoverable schedules ensure correctness, cascadeless schedules improve safety, and strict schedules are most preferred due to simple and efficient recovery. I hope you all enjoy the session. Thank you.